It's recording. Okay. What does the differential equation look like? If you're supposed to write a differential equation, what does that look like? They'll eventually get there, but a differential equation has to have a derivative in it. What do the derivatives look like? dy dx, or in this case, we don't have x's and y's, we have population, dp over dt, the population over time. Okay, so our differential equation is dp dt equals, okay, if we wanted to find out the population over time, at time 0, it's what? 83,400 times by, after 1 year, 2 years, there's going to be some variable that's, it'll increase by. Okay, find the formula for the population P in terms of time. Okay, so we take dp dt and start out with the differential in order to solve, times the initial, the ending population, excuse me. So separation of variables means when you all the like variables together. So what would you do? Okay, move the dt over. Right hand on both sides by dt. When you get the p over, so divide by p. So we have 1 over p dp equals 83,400 dt. So we separate the variables, p's on one side, t's on the other. Wait, I'm sorry. I'm not using the right number. We shouldn't have 82,400. We should have the rate in here over time. Okay, I was confused too. I was wondering why there are two p's. Yeah, because we have the number of population and we have p. Okay, so have the rate, because that's what dp dt is, right? Is growth rate, population over time. That makes a lot more sense. Ooh. Okay. Okay, now to find the formula for population P. How would you find P? Integrate both sides. Okay? So we need, on the left side, when we integrate that, what do we get? Yep. Good. Okay. On the right side, even when we integrate the right side. Now, look at what we're integrating with respect to. It's not x. T. And then what comes after that? We've integrated, so dt is gone. Plus c. And technically, this one on the left also has a plus c, but we combine them all to the right to plus c. Okay? So right now, what would we do to find the formula for P? E both sides? Yeah. I know what you're talking about. It's just E that outwards. E both sides. Okay? So we get the population would be e to the 0.047 t plus c. Do we have another way to write that? C can go, because neither can just go down. What? Go goes in front as a big E because what this really is, if I separate these terms out, I have that plus, or not, plus, times e to the c. And e to the c is a constant. So I can't just bring the plus c down, because it's not being added, it's actually being times. Okay? So I get p equals, and we usually do a big C for that, e to the 0.047 t. Yep. Okay, so now, that's our formula in terms of t. So if we had, let's see, our growth rate is 0.047, and population of P of 0 is 83,400, what could we say P of T would be? So it says the current population is P of 0 is 83,400. So its current population is saying the initial population, and when it says the times T equals 0. The current population would be the population over time, because it's probably been growing for a while. Equals e to the 0.047, and t was 0. Oops, that's up. There we go. Okay, and e to the 0 power is 1. So we find out that actually c, in fact, is what DC was saying anyway. There's too many zeros. Okay, so you're right. P of t is 82,400 e to the 0.047 t. You should show it. Okay, then the next one. Suppose the population of an ant colony increases at a rate proportional to the amount presently presented initially. So there's a key phrase that's in 1 and 2. I guess no one doesn't have it. But yeah, if it's increasing or decreasing proportionally, that should be a clue to you. What type of problem is it? What are these kinds of problems? Exponential. Okay, so let's talk about a differential equation for these ant colonies. Differential equation should have a derivative. P dt, right? Again, we're talking about population and time. So the P dt is a rate over time. So it's our rate times whatever time we're looking at. Okay, so that's your differential equation. Yeah, we're still talking about population over time. It's still dPdt. Oh, you mean over here. Yeah. That should be a P. Okay, because, yeah, the population will be times by the rate. Okay, if there are 2,000 ants present initially, and the population quadruples in 5 days, separate the differential equation in part A and write the equation for the population of the ant colony at time t. Okay, you go ahead and try that on your own. Find the equation of the population of the colony at time t. And sometimes for that R, we also see it as a K. So just sometimes the rate is R, sometimes it's K. Can I get your pen? Can I get your pens? John, do you have a pen? Okay. Does anyone have the formula for the population? Yeah. What'd you get? Yeah. Because we separated variables, right? Times dt divided by p, divided by p. This looks familiar, pretty much exactly what we did on the other side. Our times, or our, remember dt is the width of those rectangles. Yeah, but our variable is t, so r will be a constant that we plug in, because the variable is the t. Versus over here on the left side, p is the variable. Okay, so we get natural log of p plus, not plus, equals rt, because r is a constant, plus c. E both sides. I'm just looking for a formula right now. E to the RT plus C. So P equals C e to the RT. Now if you wanted to solve the problem, we have the population quadruples in 5 days, and there are 200 ants present initially. Present initially means time t equals 0. Okay. So if we started, maybe we started observing today, but there are probably ants before today. We're just saying at time t equals 0 when we started observing, there's 2,000 ants. So that's, we're going to put that as that's the population over time. C e to the RT, what's the rate? We don't have it, but do we know the time? What's the time? 0. So it's actually not a big deal that we don't know the rate, because e to the 0 is 1. So we actually find out that C is going to be 2,000. So our population over time is 2,000 e to the RT. Okay. Let's see what any other information we have here. And 5 days, what happens? Quadruples. So what? Well, C, our initial time was 2,000, and over time it quadruples. So how much will be there in 5 days? P of t will be 8,000. Because we don't know the rate, we do know the time is 5. Okay. So So I'll find the quadruples times by 4. And this allows us to solve for the rate, and time is 5. Divide by 2,000. Get 4 equals e to the 5r. So what would the rate be? Ethan? Good, yep. So we get that by natural logging both sides, right? Let's cancel. Natural log 4 equals 5r. So r is natural log 4 over 5, which ends up being approximately, squigglies because we're rounding, 0.2772 5 or 2.2773. Okay? Now, if you're doing this on a test and that wasn't your final, let's see, close off R's probably, and you were going to use that number and insert it in, you should not round it and use a rounded answer to insert into your calculator. What should you do on your calculator with this decimal? You should store it. Okay? Is everyone familiar with how to store? Well, what's your calculator call it? Just STOL. And you pick a letter. Maybe you want to call it R, maybe you want to call it K. Okay, because you don't want to round this tightly until the very, very end. So then your P of T will be that 2,000 e to that decimal of the exact form is that. Okay, make sure you don't actually round the decimal when you're in the middle of the steps, round at the very, very end. Okay, flip me over. If the half-life of a radioactive substance is 8 days, how much of a 10-gram sample will be left after 6 days? So in the fifth grade, would you work that one out? If the half-life of a radioactive substance is 8 days, how much of a 10-gram sample will be left after 6 days? Okay, about done? Jake, how's your group doing over there? You guys about done? Okay, so if the half-life is 8 days, how much of a 10-gram sample will be left after 6 days? What did you do? Okay, what did you say? 1/2. Okay. Okay, does it look agree? So if we plug in numbers, C is, okay, but if, with the numbers we have, C is 10, and we get 5 over here, right? E to the 8R. Okay, so we have to find the rate first. So divide by 10, divided by 10, we have 0.5 equals E to the 8R. Natural log both sides. Natural log 0.5 equals 8R. Divided by the 8. This is what you guys got for the fraction. I would like you to show each step. As long as you're showing that you know there's a C there. Okay, so what do you put the decimal approximately for the rate? Yep, 8.0866. Okay, now this you would store in your calculator. Okay, you're going to store and then pick a letter, alpha K or alpha R, whatever you want to call it. Okay, so how much of the sample will be left after 6 days? The population after 6 days, P of 6, is 10 e to the, we have natural log 0.5 over 8, or you can call it R if you've shown that that's what R is, times 6. So how much of the sample will be left after 6 days? 5.94. And what does this represent? Grams. Yeah. Left of the radioactive substance after 6 days. You need to have a unit, just like that. Okay. Flip to the very back number 7. We'll get our step code activity, and if there's time, we'll do another aspect. Okay. For dy dx equals x over y, draw a slope curve for the given graph. Do not draw undefined slopes. Remember, this is activity doing colored pencils. Okay, so remember you're plugging in each individual point. And here, I'll see it up. You want. Colors. Okay. When we plug in, say, the point 0, 0, what do we get? 0 divided by 0 is, well, it's an indeterminate form, so we're not going to put anything there. But if we plug in this point right here, 0, comma 1, x is 0, y is 1. 0 over 1 gives us 0. So that's a flat slope. Where else will we have a flat slope? Whenever x equals 0. So every point on the y-axis will all have a slope of 0, except for 0, 0 itself. Okay? Then we plug in and then go over to the x equaling 1. How about this point? 1 comma 0. Undefined. So it says do not draw the undefined slope, so I'm not going to put anything there. What about 2 comma 0? Everything on the x-axis is going to be undefined because we can't divide by 0. Okay, so let's jump up to 1, 1. 1 over 1 is 1. 1. So 45-degree angle, what about 2 over 2? And 3 over 3. All of those will be positive 1 slope, right? Is there anywhere where we're going to have a negative 1 slope? Quadrants 2 and 4, for this point right here. So you plug in a negative 1, comma 1, negative 1 divided by 1 is negative 1. Negative 2 divided by 2, negative 3 divided by 3, because we have opposite signs, so we get a negative slope. And then you go through and you fill in all the rest with slopes. Okay? We're going to skip ahead and do part B. Sketch the curve of y equal, I can't read that. If y 2, well, maybe we need a few more slopes. Okay, you get the ramp such a curve, we probably need at least the first quadrant here. Okay, so we plug in 1, comma 3, that'll be 1/3. Is that steeper or less steep than the 1 over 1? Less steep, so it's flattening out. This one is 1 over 4, even less steep. And here we get 2 over 3. Okay. So we want, and let's finish this. 2 over 1, it's steeper, isn't it? And this one's 3 over 1, even steeper. And this one is 3 over 2, which is 1.5. So the bottom right-hand side is steeper. The top left-hand side of that quadrant is starting to flatten out. So sketch the curve if y of 2 equals 1. What kind of I say? 2 equals 1. So looking right there. And 2 equals 1. So where would the curve go from here? And so this is some kind of a derivative. So it's showing the slopes. And at 2 we get 1. Height of 1. So we just follow the slope curve. It's going to go something like that. On the right hand side it's going to get steeper. Just follow the curves. Solving a differential equation is what we did with all of exponentials. In solving the differential, and the differential means there has to be a derivative in it. dy dx in this case versus dp dt. To solve, you have to do separation of variables, get all the x's together, all the y's together. Okay? Alex, what would you do first to separate the variables? Both sides times by dx. Okay, anything else that's going to move? Times by y. I'm just going to cheat a little bit and do that in one step. Oops. Okay, so I have y dy equals x dx. Okay, we integrate both sides. We have 1/2 y squared, because we increase the exponent, equals 1/2 x squared plus c. Now what does it mean to solve the differential? Solve for y. So we're going to times by 2 on both sides. What is a times 2? We're going to see, crazy, huh? So we get y squared equals, those 2's cancel out, x squared plus, we just still call it c, and then it's 2c, it's still c. And then we square root, but careful here. Y equals, what happens when the square root of c is still just c. Okay. Actually, I like, we need to extend that all the way over, but it's because it's square root of x squared will just become x. What happens when we take the square root? When we apply the square root ourselves? What am I missing? Plus or minus. Now we have some information. We know when y of 2 equals 1. So what we need to do is we need to use this information to find the value of c, so we have the full equation now. We only do it on the right hand side. Well, actually, no, I didn't. We'll do it on the left. We're solving for y, though we're not solving for negative y. So if this was plus or minus y, the positive y would equal that, and then the negative, we just divide by negative 1, and just move the sign over there. So we just want positive y. Okay, so let's plug in y of 2 equals 1. So y will be replaced by which number? 1. So this 2 would be x, plus or minus square root of 2 squared plus c. And actually, in this case, we're looking at the positives because y of 2 is positive, so we only have to look at the principal root, 2 squared plus c. And if we solve it, square both sides, because we're only looking at the first quadrant. Everything was positive in the first quadrant. 2 comma 1. So we get square root of 4 plus c. Oops. It's just 4 plus c. Minus 4 minus 4. So c is negative 3. So it's 2 squared. X squared. Squared. And then you have to square both sides, which cancels out the square root. 4 plus c, so c is negative 3. So our function is square root of x squared minus 3. And 2 comma, or 1 comma 2, well, no, it's 2 comma 1, it's 2 is the x. 2 comma 1 is in the first quadrant, so we really have to look at the principal root. You can see on the graph, it's not going to go into negatives because it can't jump below here. Okay, we're going to do an activity. We really have time. On split fields, I have a set of differentials, split fields, and cards that explain what is going on. You, as you with your group, you need to match them up. Okay, and there's a number on them. So in about 10 minutes, maybe lay out all the split fields, get one person's desk cleared out. Now remember that if everything matches horizontally, that means what variable is in the differential? The y. If everything matches vertically, the x is in the differential. Okay? So we have the slope fields. Now that one, x over y, is one we just did, right? And on this worksheet, once you solve them, write down the slope field number 1 matches which differential, which matches which conclusion. can just write down a number. Okay. What I would like you to do with these cards, and give everyone a set, that you at least have some conversation you've started before you wrote them down. I want you to take your own individual set and glue on, like, figure them out yourself and glue them on like a poster board or a piece of paper if they fit on just a piece of paper. Okay? So I cut out the green ones for each person. Mm-hmm. Glue them across your green, your yellow, your blue. I guess it goes. Yep. Okay, so there's a green one. Here's a yellow one. And someone can take the ones on the table. Can't undo that. Those ones already cut out, so. Okay, there's the blue ones. Put yours in the baggie. Four. Okay, so I'm going to make sure you have yellow, green, and blue.